If you program Dynalite projects long enough, eventually you're going to run into a trunk and spur project. When that happens, it's going to be important to think about where you're connected to the network. Today, I'm going to demonstrate this principle through an example of how to bench program a sensor or a UI to send a site either as a replacement device or maybe in addition to the system. Let's get into it. Since I get this question about 10 times a year, I think it's a good topic to dive into and to look at where this goes off the rails. But first, before we get too deep into the trunk and spur part, let's just talk about how you would replace a device on a basic single spur project. So step one is to wire up your device on the bench. So we've got our sensor here, we've got our PC node, but that's not enough because the USB on the PC node is not going to be enough to power that sensor. We also need network power. So either grab yourself a power supply or a spare load controller to get everything fully powered up. Step 2, open your project file. Step 3, connect to the network with your PC node. It doesn't actually know geographically where you are. It just knows that you have told it you are connected to the network. Step 4, open Insert Devices from Network and sign on your sensor. If its box number matches any that are already on site, go ahead and change it. Step 5, drag and drop that sensor you discovered onto the sensor it's replacing on the plan or the system view. Last but not least, step 6, save to the sensor. It's that easy. Now you can just box it up and send it to site. That's really all it takes to bench program a replacement sensor for a single spur job. All of that is super simple and can be summed up as drag and drop the new sensor onto the one it's replacing and save. At least it's simple until you add network translations. Where things fall off the rails on trunk and spur projects is when people fail to think about where they're connecting to the network. When you connect to a project with a PC node, you're almost always connecting to a spur. When your project only has one spur, there's really no difference between the spur or the trunk. However, when you get to a trunk and spur project where you have multiple spurs, it actually makes a big difference whether or not you're connected to a spur or a trunk. In order to make a trunk connection, you select the project name and make a trunk connection via the machine connection settings. You can do this with either serial or IP connections, but typically these days it's IP connections. This works well if you have a single spur because all the messages are untranslated messages. However, once you add multiple spurs and network translation, where you're connecting to the network tells System Builder what type of messages to send. Let's see what happens when we try to bench program a sensor with a trunk connection. As you can see, the box number assignment fails. That's because we told System Builder we have a trunk connection, and it's expecting sensors to show up with a box number starting with 1000. This is where most people go wrong. What we actually need is a spur connection. To do this, instead of selecting the job name, select the gateway you want to connect to. In our case, we want to program this sensor for the first floor, so that's the gateway we're going to select. Then we make a spur connection. Essentially what we've told System Builder is that we're on site and that we either pulled an Antumbra off the wall and plugged in with that fancy new dingus that comes with the PC node, or perhaps we plugged into the Dynet port on an Ethernet gateway. Because we've told System Builder we're on the spur, it will now send and look for untranslated messages. One way to tell that you successfully have a spur connection is by looking at the connection in the corner or noticing that that spur is now in color and all the other spurs are in grayscale because you can't talk to them from spur to spur. You have to be connected to the trunk if you want to talk to more than one spur at a time. Now, when we drag and drop, System Builder expects and accepts a D1 box number. All that's left is to save to the device and ship it to site. But don't forget to save your project file with the new box number and upload it to the Dynalite cloud so the next person that goes to site has an accurate file. And there you have it, remotely programming a new or replacement device for a site is quick and simple. Just make sure you tell System Builder where you are connected to the network. This only scratches the surface of all the tricky things that can come up on a trunk and spur project. If you want us to cover other topics like common areas or the pros and cons of RS-485 versus Ethernet trunks, leave a comment below and let us know. Thanks.